This is demo 2 of 2 demos that simulate a ride-sharing application. The simulation is contained in a web page using Google Maps for display. If you have not already viewed demo 1, you should do this first before viewing this demo. Like demo 1, this demo attempts to show a real-world application that can be executed in Ritc using rules, in this case a simulation of Uber Pool. In January 2015, an Uber VC, Bill Gurley, blogged about how this was a BHAG, a big, hairy, audacious goal, something to be solved by the Uber math department. Well, Uber has clearly solved this challenge, but this demo will show how it is quite doable in Ritc with just a few rules. The demo sequence goes like this. After retrieving the historical rides, modified slightly from Socrata, the simulation sends each passenger request with the appropriate delay to the Ritc rule engine using the Ritc API. Ritc tries to match the request with a nearby driver already carrying passengers, where the new passenger is heading in the same direction, is on the driver's route, ahead of the driver, and the driver has extra seating capacity. In terms of requirements, this is probably similar to what Uber Pool does. Like Demo 1, there are 2 rules, handling only Uber Pool-like use cases. In real life, depending on the business model, there could very well be a mixture of rules which try first for a driver not carrying passengers, and if not found, a driver already carrying passengers, or the other way around. The 2 rules are: rule number 1. Receive the driver status updates, indicating the driver coordinates, heading, and number of passengers, and store them in the database. In real life, this rule should be invoked by each moving driver, say every 30 to 60 seconds, to keep the database up to date. Rule number 2. In this demo, only one rule is used to attempt the match. The rule has 4 triggers. Trigger number 1. Receive the passenger pickup request. Trigger number 2. Using the passenger coordinates sent in the pickup request, it looks for moving drivers in the database who are already carrying passengers and have the same destination as the new passenger. Trigger number 3, it uses the Google Direction Service, Distance Matrix API, and Geometry Library to find drivers where the new passenger is on the driver's route, ahead of the driver, and is heading in the same direction. It chooses the nearest one. Trigger number 4, at this point, this simulation assumes there is a match and sends the Start Your Trip instructions to the driver. The rule action is to return the results to the caller. As in Demo 1, the passenger request, pickup, and drop-off entries are shown on the right. The times in milliseconds that the rule engine takes to attempt and execute the rule is shown in parentheses next to the pickup entries. And like Demo 1, the rules in this demo could be used to build a real-world application. Just replace the web page simulation with a mobile app that sends passenger pickup requests containing location coordinates, driver availability and status notifications, and any other messages that would be handled by the rule engine. Ritc listens and responds in real time. This demo exemplifies the types of applications that could be built and run in Ritc, where you have a defined population of participants, in this case driver and passenger apps, that communicate with a service that determines what to do next. Intelligence and machine learning may be involved in real time. The Ritc rules can be considered as use cases or executable requirements that can be created and managed by non-technical people.